Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When an aldopentose is oxidized, example, with HNO3, both the aldehyde, ChO, and the primary alcohol, CH2O, are converted to carboxylic acid, COO groups, yielding an aldaric acid, saccharic acid. The resulting dibasic acid is optically active only if it lacks an internal plane of symmetry, i.e., it is not a meso compound. Additionally, since we want an L sugar, the configuration at the highest numbered chiral center, C4 for a pentose, must have the OH on the left in the Fischer projection. Moving on to the next step. In pentoses, the L configuration is defined by the OH group at C4 being on the left in the Fischer projection. AC4 has HO on left L sugar. BC4 has H on left, OH on right D sugar. CC4 has H on left, OH on right D sugar. DC4 has HO on left L sugar. Moving on to the next step. Among L sugars, A and D determine which gives an optically active aldaric acid upon oxidation. Option A configuration is C2, HO, C3, OH, C4, OH, reading of positions C2 OH right, C3 OH left, C4 OH left. This corresponds to L-arabinose or a related sugar. The aldaric acid obtained from L-arabinose is arabinic acid. Check for symmetry. The acid has COO at both ends. The internal carbons are C2 OH right, C3 OH left, C4 OH left. Since C2 and C4 are not mirror images of each other relative to C3, the molecule has no internal plane of symmetry optically active. Option D configuration is C2, OH, C3, HO, C4, OH, of positions C2 OH left, C3 OH right, C4 OH left. The aldaric acid from this sugar, COO at top and bottom, C2 OH left, C3 OH right, C4 OH left. This molecule has a plane of symmetry through C3 because C2 and C4 are mirror images meso compound optically inactive. And for the final step, only option A, an L sugar with the configuration giving a non-meso aldaric acid upon oxidation, satisfies both conditions, L sugar and optically active dibasic acid. Therefore, the correct answer is A. Therefore, the correct answer is option A.